End-stage organ failure is a devastating condition that affects millions of people around the world every year. And the only definitive treatment is transplantation with a new organ from a donor. The problem, though, is that your immune system will recognize that new organ as being something foreign. And just like your immune cells are designed to attack bacteria and viruses all the time, your immune cells will start attacking that new organ, causing rejection. To suppress this, recipients of organ transplants need to take very powerful immune suppressive drugs. But these drugs come with their own problems. They can cause organ-specific toxicities, and they cause a very profound immune deficiency in the recipient that then leads to an increased risk of cancer and infection. So there's a very strong need, clinical need, for safe, alternative, and more targeted therapies for people who undergo organ transplantation. As an alternative, researchers have been looking at cell therapies using a specific type of cell called a regulatory T cell. Now, regulatory T cells are immune cells as well, but they're very special because unlike other immune cells that are designed to attack and kill foreign molecules, regulatory T cells are there to kind of make sure everything stays under control, and they specifically suppress other branches of the immune system and calm down excessive or unwanted inflammation. As a result, these therapies are now moving into clinical trials for organ transplantation. And what's even more exciting is that researchers have come up with ways to genetically engineer these regulatory T cells so that they recognize a specific molecule that's only in that new donor organ. This allows the regulatory T cells to traffic to that new organ and exert very powerful immune suppressive effects, but in a targeted and highly localized way that doesn't compromise the integrity of the overall immune system. These therapies, again, are now in clinical trials for transplantation, but several challenges remain, and these therapies are most definitely not perfect. First, all of the therapies we have right now target the same molecule within that donor organ, but there's many other molecules in that donor organ that can also drive these immune responses in this rejection process. And second, these therapies, once they're infused into living hosts, do not persist for long periods of time. And that's where my research comes in. So first, I'm developing regulatory T cell therapies that are targeting a new donor molecule that's present in the organ and also drives this rejection process, looking at extending the breadth and the coverage of these immunotherapies. And second, I'll be genetically tweaking these regulatory T cells so that they persist longer once they're infused into patients. So far, I've made great progress. I've shown that my regulatory T cell therapies are potently suppressive in cell culture systems, and I'm now moving to test them in living models of heart transplantation. My hope is that one day, patients who undergo organ transplantation could receive a single dose of these targeted regulatory T cell therapies to promote sustained immune tolerance and long-lasting organ function. Thank you.